friends, welcome back. Today we'll write a Java program to implement a queue and handle its exceptions using throws mechanism. So we'll be writing exceptions for overflow condition and underflow condition. So let us understand what is queue data structure. Well friends, a queue is a linear data structure which follows a particular order in which operations should be performed, and the operations are insert and delete operations. Insert operation is also called as enqueue operation. Delete operation is called as dequeue operation. And the principle or the order in which these operations are performed are first in, first out. FIFO. Okay, so queue follows the principle FIFO. F-I-F-O. So any element that you want to insert into the queue, you will be inserting it at the end, and the deletion operation happens from the front. Whichever element enters into the queue first will be the first to come out of the queue. Let us try to understand this with a real life analogy. So say there is a milk booth, and this milk booth is the resource, and the people wants to come to the milk booth to get the milk. Okay, so say there is a person. So a person is coming to the milk booth. So he is standing in a queue to get the services from the milk booth, that is to get the milk. So say there is another person. So another person is also coming to get the milk. Now where do this person stand? So this person has to stand in a queue. He should stand next to the person who is already in the queue. So he has to stand after the person. Okay, so this is called as queue. So you can see consecutively people are coming, but they are standing in the queue. Okay, so you can see they are standing one after the other. In the similar way, inside the queue also, whenever you want to insert elements into the queue, they have to be inserted one after the other. So they will be inserted at the rear position. Rear position is nothing but at the end of the queue. Okay, right. So this is called as enqueue operation. See friends, like the people are standing in a queue, and also who will be served first among these 5 persons. Okay, so whoever has come first will get the milk first. Okay, so that is what is called as first in, first serve. So we'll see the dequeue operation. So for the dequeue operation, the person who is in the front of the queue will get the milk and he'll leave the booth. So this is the person, so he got the milk and he left. So now the second person became the first in the queue. Okay, and again he gets the milk and he leaves the booth. The third person now became the front of the queue. Okay, he became the first in the queue, and he will be taking the milk and he'll be going. And see friends, at the same time 2 operations can be performed. So you can see clearly that an dequeue operation happened at the same time an insert operation is happening, but they don't clash because the dequeue operation happens at the front of the queue and enqueue operation happens at the end of the queue. So they can happen. It's not like only the inserts happen and then the deletes happen. No, there can be people entering into the booth, and also there can be people going out of the booth also. Okay, so this is a simple queue structure friends. Okay, so let us try to understand this. So for the enqueue operation, now let me tell you that to implement a queue, we need to do it either in an array, implementing it in an array, or in a linked list. So herein I am showing you how to implement it using an array. So initially there are no elements in the array and the size of the array is 5. Okay, and the index values of the elements start with 0. So there are only 5 positions for the elements to be inserted. So initially front and rear will be -1 and -1 because there are no elements. So front is equal to -1 and rear is equal to -1 represents that the queue is empty. Okay, so say I want to insert 23, 32, 11, 10, 5, 16 into the queue. Okay, we'll start inserting. So that is enqueue operation. So as soon as we insert 23, front and rear will become 0 and 0. Now why do we are having 2 variables over here to represent? to represent the queue. Okay, so front always represents the first element in the queue and rear always represents the last element in the queue. Okay, so whenever you are enqueuing, meaning that whenever you are adding an element into the queue, you will be incrementing the rear position, and whenever you are deleting an element from the queue, you will be incrementing the front position. Okay, so 23 is inserted, so front and rear comes and points to the first position in the array. So I want to insert 32 into the queue. So when I inserted the next element, as I already told you the milk booth analogy, so you can see that they are added at the end. Okay, rear gets incremented. Now rear is equal to 1. See here friends, front is always pointing to the first element that is inserted and rear is pointing to the last element that is inserted. Okay, so these two are the pointers of the queue which will point to the front and the last element, first and the last elements. So I want to insert 11 into the queue. So rear increments and then the element is inserted. So in the same way, like the decrements also can happen, but initially I am showing you the enqueue and then I want to show you the overflow condition. So I want to insert 10 into the queue. So rear gets incremented. So there is room also for 10 to insert. So rear got incremented and 10 is inserted. I want to insert 5 again. So when I inserted 5, rear become 4. Now see friends, the queue is full now. Okay. So since the queue is full and I want to insert 16, now we'll see what happened. Because there is no place for 16 to get inserted, so overflow condition occurs. Overflow condition is something which will tell us that the queue is full. Okay, there is no room for more elements to be inserted into the queue. Overflow condition indicates that. Okay, and what is the overflow condition? The condition that we will be writing, the logic that we will be writing is rear is equal to size of array minus 1. So the size of the array is 5. 5 minus 1 is 4. So whenever rear becomes 4, size of array minus 1, then and then you are trying to insert one more element into the queue, then the overflow condition occurs. Okay, so this is enqueue operation friends. And coming to the dequeue operation, so front is equal to 0 and rear is equal to 4. As I already told you, so the deletions happen like first in first out. So the first element inserted is 23. So the deletion also 23 is the first element to be deleted also. Okay, so 23 gets deleted and front got incremented and it goes to the next position. So after 23 is deleted, the first element in the queue will be 32. Okay, so front always will point to the first element inside the queue. So this is the status. And now I want to delete 32. Okay, so when I want to delete 32, front again got incremented and went to the next position. Okay, so this is what happened. And I want to delete again. Okay, so again front incremented and the first element in the queue is 10 now. I want to delete 10 now. Okay, so front again got incremented and it went to the last position. See here friends, now in case if I want to insert one more element into the queue. So I want all of you to pause the video and think of it. I want to insert one more element into the queue. So will I be able to insert into this queue? Okay friends, no, because this is simple queue and which is rear is equal to size of array minus 1. So since rear is equal to size of array minus 1, so you cannot insert more elements into this simple queue even if there is room for more elements to be inserted. That is a drawback in the simple queue friends. But elements into the queue when there is place for elements to be inserted. That concept is called a circular queue friends. Okay, fine. So this is the dequeue operation, and so the underflow condition occurs when you want to delete more elements from an empty queue. Okay, if you perform dequeue operation on an empty queue, then the underflow condition occurs. Underflow condition indicates that there are no elements to be deleted from the queue. Okay, so when you want to delete the last element, so I want to delete 5. So what happens? The queue became empty. So again front and rear became minus 1. Okay. So this is enqueue and dequeue operation performed on a queue. Okay. So now we'll see the overflow condition and underflow conditions. I am creating the overflow and underflow conditions as exceptions. For doing that, I am creating a class overflow which extends the exception class. Automatically an user defined exception is created, which is overflow. In the similar way, I have created an underflow exception by extending the exception class. Okay friends, so this is the enqueue operation. So enqueue operation is throwing overflow. So throws overflow indicates that this method, which is enqueue, is capable of throwing an overflow exception. So these are all the logic. So if rar is equal to 4, because I have taken the size to be 5. So if rar is equal to 4 and you still call the enqueue operation, so what happens? It throw new overflow. Okay, so it creates an exception and it throws that. Okay, and else if this is a case where you want to insert first element into the queue. So wherein front is equal to -1 and rar is equal to -1. So there are no elements, and the element that you want to insert is the first element. So then you are making rar and front to be 0, and then you are inserting the element y into the queue. Okay, so this is the first element inserted. And if it is some other element other than the first element, then you will say else q plus rar is equal to y. So this is enqueue operation. And this is delete operation, dequeue operation. So dequeue operation throws underflow condition, okay, exception. So it throws underflow. Underflow is an exception that we created. And if front is equal to -1 or front greater than rar, okay, throw new underflow. Okay, front is equal to -1, meaning that there are no elements, queue is empty, and also front greater than rar. So say there are only 2 elements and the 2 elements are deleted. In that case, front will cross over rar. So in that situation also, we are saying front greater than rar. In that condition also, the queue is empty. So in that case, we are asking to throw new underflow exception. In the else part, we are showing the element that is deleted and we are incrementing front. Okay, so this is enqueue and dequeue operations, friends.